Welcome back. Okay, until now, we have been talking about different ways that we could use the derivative and the second derivative in order to find out information about a graph, where it's increasing, where it's decreasing, and what our concavity is like. Now we're going to take all of that information that we've learned, relative maximum, relative minimum, extrema, things like that, and use it to actually sketch a curve. So when we're sketching a curve, the first thing we should do is find our domain and range. Then we should find x and y intercepts, vertical, horizontal, slant asymptotes, symmetry of our graph, critical points and intervals where we're increasing and decreasing, our local maximum and minimum points, our concavity and points of inflection, and then just actually sketch the curve. So you already know how to do all of this, and now we're going to throw it all together. So we've been given a function, f of x is equal to x cubed minus 6x squared plus 9x minus 2. All right, so first I'm going to talk about our domain and our range. It looks to me like our domain is kind of going to be all real numbers, or you could say from negative infinity to infinity, and our range the same, all real numbers or negative infinity to infinity. That's nice. That means that we don't really have a lot to kind of deal with domain and range, and we can just draw this graph as we would. Next, so we found domain and range, our x and y intercepts. Well, I'm just going to find our y-intercept. Our y-intercept is pretty easy. You put in 0 for x, and we get 0, comma, negative 2? Ooh, negative 2. It's not so easy that I didn't do it right? Negative 2. So we have a y-intercept at 0, negative 2. I can actually just graph that right now. Good. There, I've got my y-intercept. I know my graph's going to cross through there. Now, I want to find out where I'm increasing and decreasing and find these critical points, right? So I'll find f prime of x. F prime of x is equal to 3x squared minus 12x plus 9. That's a fun little function there. I'm going to factor out a 3, so I get x squared minus 4x plus 3. I need to set these equal to 0. So I have 3. I'm factoring. We get x, we get minus 3 minus 1. So x could be equal to 3 or x could be equal to 1. These are my critical points, and now I need to test them using the first derivative test. I'll do that over here. So I've got 1, 3. I guess here I'll test 0, here I'll test 2, here I'll test 4. And you know my old trick, just put it in the calculator. So 3x squared, what am I doing? 3 times 0 squared. Well, this is going to be positive, and so, okay, so back to this. 0, if I put in 0, f prime of 0 is equal to 9, so that means this is increasing. And then if I put in 2, I did it in my calculator over here, then that is equal to negative 3, and so that is decreasing. And if I put in 4, we are going to get something really good. A 9, that's positive, so that's increasing. So now we know that we are increasing. I can just write this here, I guess, increasing from negative infinity to 1, whoops, and then again from 3 to infinity. Okay, cool. And I'm decreasing from 1 to 3. All right, that's good information. Now I need to know what my relative minimum and relative maximum are, and I can actually find this here. So I'm going to have a relative maximum at 1 comma, and I have to put in 1 back into my original equation. So I'm going to do that here. I'm going to have 1 cubed is 1 minus 6 plus 9 minus 2 is 2. So I have a relative maximum at 1, 2, and I have a relative minimum at, I'm going to have 3 cubed is 27 minus 6 times 9 is 54 plus 27 minus 2 is negative 2. So 3, negative 2, I've got a relative minimum. Okay, now I still need to find my concavity. Where am I concave up? Where am I concave down? So f double prime of x is equal to 6x minus 12. I'm going to set that equal to 0, so I take out a 6. I've got x minus 2 is equal to 0, so x could be equal to 2. So I need to test that. All right, I've got 2. I'm going to test 0 and 3. If I put in 0, I get a negative 12, so that's concave down. And if I put in 3, I'm going to get 18 minus 12 is positive, so that's concave up. Okay, so looks like I can kind of graph this, right? So I'm going to put in my relative minimum and my relative maximum. Relative maximum was at 1, 2, and relative minimum was at 3, negative 2. I'm just going to extend that graph there just so we can kind of see it. And from negative, looks like we're concave down until 2, right? So from negative infinity, I guess I didn't write that down, but we have a point of inflection. This is our point of inflection. At where? Well, our point of inflection is going to be at, I need to put in 2, so I'm going to have 8 minus 24 plus 18 minus 2, and that's equal to 0. So I have a point of inflection at 2, 0. So I'm going to put that right there. And now I can finish graphing. So I know that I'm going to be concave down. This isn't well drawn. And then I'm concave up. And there. I've got it. Okay? That's it. We did curve sketching. All right? I'm going to do one more example. I think that made sense, but I want to do one that's a little bit more complicated just to kind of re-emphasize how this works. So I'm going to find, here I have f of x is equal to x squared plus 1 over x squared minus 9. If I were you, I would speed up through this because I'm going to find the first derivative. You know how to do it, but I'm just going to work through it. Minus x squared plus 1 times 2x. Yep. So this is going to be, just trust me that this simplified. Nobody wants to watch all that happen. So where are our critical numbers? Our critical number is at x equals 0, and x cannot equal plus or minus 3. As you can see already, this is already a more complicated graph, okay? Then we want to find f double prime of x, okay? F double prime of x. Please just trust me that it's going to be equal to 60 times x squared plus 3 over x squared minus 9 cubed. Again, I know that you know how to do this, but I'm just not working through all of it. You found a derivative. There's no point in watching me do it. So 60 times x squared plus 3 cannot equal 0. So we don't have, there's no point of inflection. Okay, no POI, no POI. All right, so let's actually deal with our, you'll see this, watch when I do our second derivative test. All right, so first derivative test, we have negative 3, 0, and 3. So I'm going to test negative 4, negative 1, 1, and 4. All right. If I test negative 4, that's positive, so I'm increasing. If I test negative 1, that's positive, so I'm still increasing. If I test 1, it's negative, I'm decreasing. 4, negative, I'm decreasing. All right. Our second derivative test, we had second derivative, like x could be equal to plus or minus radical 3? Well, not exactly. I think what I need to do here is show you kind of how this graph is looking, right? So let's go here. I'm going to show you this graph. We've got our graph here, and we've already talked about how x cannot be equal to plus or minus 3. So at plus or minus 3, that's when we're going to have our vertical asymptotes, right? So we've got a vertical asymptote here. We've got a vertical asymptote here. Okay. What is our, oops, can you see all of this in the, I might have to zoom out a little bit. Okay. So we have a critical number we decided at 0. Well, at 0, we were increasing and then decreasing. So we need to find out what 0 is. It looks like 0, we're going to have our relative maximum. Relative maximum at 0, comma, and we're going to have negative 1/9, it looks like. Negative 1/9? Is that right? So maybe that's like, it's not in a great spot, but 0, negative 1/9 might be right here. So our graph, this is so poorly drawn, but it's going to continue like that, right? We're going from negative, we're increasing, and then we're decreasing, right? So we have also a horizontal asymptote. Well, where's our horizontal asymptote? Well, that's going to be at 1, okay? So our horizontal asymptote is going to be at 1. And hopefully now you're kind of getting to see what's going on with this graph. Well, that 3, we were, when we tested at 3, we were decreasing. We're still decreasing here, right? So we're decreasing here. But at negative 4, which is going to be over here, we were increasing. So this is going to look like this. So that one's a little bit more complicated, and hopefully you can kind of see what that graph looked like and kind of came out to be in the end. There's a lot going on. This actually ended up not being useful to us, but that is a more complicated graph, okay? So last thing I want to talk about here, or actually 2 more things I want to talk about here. So if we are given a function f prime of x, could we sketch a graph given f prime of x? Could we sketch the graph of f of x? Yes, we definitely can. Okay, so the first thing we're going to do is find out where our zeros are. Well, we have a 0 here, and then we have a 0 here, right? So these are our extreme values. So these are going to be relative maximum or relative minimums, right? If f prime of x is above the axis, then that means it's increasing. So from here, from negative infinity to here, it's increasing. And then from here to here, it's decreasing. So if this is increasing, then decreasing, we must have a relative maximum, right? Right? And then if we have from here, it's decreasing, then increasing, we must have a relative minimum. Okay? So far, so good? So just know relative maximum, relative minimum. Then we want to do our second derivative. We know that if f prime of x decreases, then f double prime of x is less than 0 and vice versa. So wherever we have a 0 slope, we might have a point of inflection. So here, this is going to be our point of inflection, right? Our point of inflection is going to be somewhere along this axis, right? So if this is our graph, and look, oop, there's my point of inflection, and that's it. So we can kind of sketch that curve also. We just sketched f of x, okay? Good? All right, the last type of problem that will be on your homework assignment, and I just want to go over it to say, you know, it's here, okay. We want to sketch the graph of a single function that has all these properties listed. So continuous and differentiable for all real numbers, that's nice, no discontinuities. F prime of x is greater than 0 on negative infinity to negative 3 and from 1 to 4. So let's say this. I'm going to draw my first derivative test, my f prime of x. So from negative infinity to negative 3, looks like we're increasing, and from 1 to 4, we are increasing. Okay? So, but it's less than from negative 3 to 1 and from 4 to infinity. Okay, so, oh, this should be a negative 3. Negative 3 to 1, decreasing. And from 4 to infinity, we are again decreasing. Okay, there's our first derivative test. Now let's talk about the second derivative. Okay, so from negative infinity to negative 1, it's less than 0, so concave down. From 2 to infinity, it's less than 0, concave down. But from negative 1 to 2, it's greater than 0, so it's concave up. F prime of 3 is equal to f prime of 4, which is equal to 0. So that means that we're going to have some relative maximum, some extrema, relative maximum, relative, looks like to me, because we've got negative 3 and 4, this will be a relative max at negative 3 something and at 4 something. And then f double prime is equal to 0. So we're going to have, if it's double prime is equal to 0 at negative 1, 3, and 2, 4, those are going to be our points of inflection, right? Our points of inflection. So let's draw this. Okay. 1, 2, 3, 4. So at negative 1, 3, we've got a point of inflection. At 2, 4, we've got a point of inflection. At negative 3 something, we've got a relative maximum, and at 4 something, these are equal, we've got a relative maximum. And then we can just draw this, okay? So our graph is going to increase, decrease, point of inflection, point of inflection. I didn't draw this very well. Something kind of like that. Really, again, very poorly drawn, but hopefully you get the idea. These don't have to look perfect, obviously, and of course you have a graphing calculator to check these with, but that's the general idea of curve sketching. I think it's kind of time consuming, but not necessarily hard, so hopefully you could kind of make sense of it. If you have any questions, leave them in the comments, and I will see you in class. Bye!